Good morning, class 8. Today we will read lesson number 9, carbon and its compound. So first of all, the symbol for the carbon is C, atomic number is 6, mass number is 12, and valency is 4. If you will do the electronic configuration of carbon, it will be 2 and 4, that is, it has got 4 valence electrons in its large shell. This is the orbit diagram of the carbon, that it has got 4 valence electron. So carbon, it is the basis of the life, because all living organisms it contains carbon. So carbon, it is the most widely distributed element on the earth, and after oxygen and hydrogen, it is the third most element, which is it is the third most element for the existence of the life on earth. So the name, the carbon, it's a word which is derived from the Latin word carbo, which means core. Now, occurrence of carbon. So carbon occurs in the earth crust in free as well as in the combined state. You can get the carbon in the free state as well in the combined state. In free state, it occurs as coal, diamond and graphite. In the form of coal, diamond and graphite, you can get it in the free state. And in the combined state, it can occur in the atmosphere as carbon dioxide, and natural water as dissolved carbon dioxide, and natural gas and petroleum also from natural gas and petroleum, and from food nutrients like carbohydrates, fats, proteins, vitamins. All these contains carbon dioxide, carbonates and bicarbonates such as chalk, limestone, marble, calamine, washing soda, baking soda, shells of many aquatic animals, they are made up of carbonates. So natural fibers like cotton, silk, etc., all these contains carbon. Okay, so these are the ways by which you can get the carbon in the free state as well as in the combined state. So carbon, it's a unique non-metal and it has different forms and properties. In the form, mankind use it in the form of the charcoal and sweet, and so mankind use this carbon in the form of charcoal and soot. Now here there are different forms of the carbon. You can have carbon in marble, calcium carbonate, chalk, diamond, graphite, coal and wood also. Okay. Now, although carbon consists only 0.03% of the earth crust, it forms enormous large number of the compound. And so due to this, there are so many large number of compounds of carbon. There is an entire branch of the chemistry called as the organic chemistry, in which you study about carbon and its compound. So organic chemistry, it's a term which is given to the branch because most of the carbon compounds, these are obtained from the living organisms. So for the convenience of the study, all compounds we have classified into two: organic compounds and inorganic compounds. So organic compounds, they contain carbon as a constituents. And few examples of useful organic compounds are starch, wax, vinegar, alcohol, dyes, detergent, soap, plastic, clothing material like nylon, polyester, silk, wool, cotton, as well as paper, polythene, perfume, disinfectant and many other medicines. Okay, these are the name of some compound which contains carbons. These are the hydrocarbons, alcohols, acids and sugars. All these contains carbon. So such a large number of organic compounds you have got which contains carbon. Okay, now here is the list of the inorganic compounds. Carbon is here is the list of the inorganic compound in which carbon is present, like in carbon dioxide, carbon monoxide, calcium carbonate, sodium carbonate, copper carbonate, zinc carbonate, sodium bicarbonate, calcium bicarbonate. So this is the list of the inorganic compound in which carbon is present in the inorganic compounds. So petroleum, it's a mixture of carbon compound found in the liquid state. Also vegetable oils are the liquid forms of carbon compound. Now oxide of the carbon, carbon dioxide, carbon monoxide, carbonates, carbonates and bicarbonates, they belongs to organic compounds. Now one of the important property of the carbon is that of self-linking, and it link with another carbon atom, that carbon atom link with another carbon atom. That's how one carbon atom link with many carbon atoms to form a long chain of different sizes, and this property we call it as the catenation. Carbon atom, it possesses a unique property to link together to form a very long chain of different sizes, which means straight chain, branch chain or cyclic. So this property we call it as the catenation. Now here we can show the presence of carbon and sugar. We will take some sugar in test tube and heat it for some time. After some time we will observe that first the sugar will melt and then it will turn brown, and finally it can get turned to black. This black substance you call it as the carbon. So this experimentally proves that sugar contains carbon. So most of the substances that leaves a black residue after heating contains carbon, like coal. If you will burning coal, wood and paper, you get a black color substance which is a carbon. It means coal, wood, paper, what they contain? They contain carbon. Now here is the carbon cycle. In this carbon cycle, what happens? The plants, they used to make their food by the process of the photosynthesis in presence of carbon dioxide, water, vapor, sunlight and chlorophyll. So they are using, these plants, they are taking the carbon dioxide from the air, and these plants we are consuming these plants. So it means that animals get organic compounds by eating the plants. And when the animals they used to get decay, they released carbon dioxide, and when they respire, when they breathe out, at that time also they give out carbon dioxide. And when we burn the fossil fuels, at that time also carbon dioxide is released. And by the decay of the plants, when the plants get decay, at that time also carbon dioxide is released. So carbon dioxide from the atmosphere is taken by the plants for the process of the photosynthesis, and then through the various processes it come back to atmosphere. So this cycle, this whole cycle, we call it as the carbon cycle. Now we will learn about allotropy in carbon. Allotropy in carbon means in which it's a allotropy, it's a phenomena or it's a process due to which what happens, there is an element and it exists in two or more forms in the same physical state. It will exist in two or more forms in same physical state with identical chemical properties. The chemical properties are same, physical state is same, but different physical properties, but the physical properties are different. So underline the definition of the allotropy. It is defined as the phenomena due to which an element exists in two or more forms in same physical state with identical chemical properties but different physical properties. So such forms of element we call as the allotropes. So allotropes, they contain the same kind of the atoms. They contain same kind of atoms, but due to difference in the arrangement. What is there? What is the difference? Difference in the arrangement of the atoms. They contain same kind of atom. They give different looks. So carbon, it also exhibit allotropy. Okay. So why carbon exhibit allotropy? Because it contains the same kind of the atoms. Allotropes of carbon contain the same kind of atoms, but there is a difference in the arrangement of the carbon atoms due to which carbon exhibit allotropy. So here the allotropes of carbon, we have divided it into two, crystalline form and amorphous form. Amorphous crystalline form or amorphous or non-crystalline allotropes. So these two broad groups or types we have further subdivided into number of specific types. So all these forms of carbon, they differ in their physical properties. Physical properties are different, but when all these things are burned in presence of oxygen, they all produce carbon dioxide with release of heat. So any allotrope of carbon, if it is burned in presence of oxygen, that it always releases carbon dioxide and heat. So they have got the different physical properties, but have got the same allotropes of carbon. They have got the different physical properties, but have got the same chemical properties. So here they have shown you the classification. This table you need to learn. Here they have shown you the allotropes of the carbon, that it is the crystalline form, it is the amorphous or non-crystalline form. It means definite structure. This crystalline form they have divided into graphite, diamond, Buckminster, fullerene, and the amorphous form is further divided into coal, coke, charcoal, lamp black, and gas carbon. Okay, these are the amorphous form: coal, coke, charcoal, lamp black, gas carbon, and further this charcoal is divided into wood charcoal, sugar charcoal, bone charcoal. When these wood, sugar or bone, they are heated, at that time you get a substance which is called as the wood charcoal, sugar charcoal and bone charcoal. So these are different allotropes of carbon which you need to learn. This table is very important. You need to learn this table for the allotropes of carbon. Now one by one we will read. We will read for the crystalline form: graphite, diamond and Buckminster, fullerene. Okay, in detail. Now here there is given proper preparation of the graphite, that how you can prepare graphite. So pure graphite you can prepare by heating powdered coke. If there is a powdered coke, you will heat it, mix with little sand or silica, and in presence of iron oxide, and in an electric furnace, temperature is 3000 degrees centigrade. So you will get carbon monoxide and silicon carbide. This silicon carbide on further heating gives you silicon and graphite. This carbon graphite you will get. So thus you can prepare graphite also. Now structure of the graphite, if you will look here, the structure of the graphite, here all of you know that in carbon, one atom of carbon has got 4 valence electrons. So in graphite what happened? Each carbon atom is linked with 3 neighboring carbon atom. Each carbon atom, suppose this is one carbon atom, it is attached with 1, 2, 3 carbon atom. This carbon atom 1, 2, 3. So each carbon atom is linked with 3 neighboring carbon atoms, thus forming a flat hexagonal arrangement of atoms. And what it will form? It will form this arrangement you call as the hexagonal, and it will form a flat hexagonal arrangement. These hexagonal group of carbon atoms are arranged as layers or sheets piled up one on top of other. So these flat hexagonal sheets are arranged on one another, and the layers and these layers they are held together by weak forces that they can slide over one another. These layers are held together by weak forces. What we call these forces? We call these as the van der Waals forces. So that's why the graphite is soft and slippery and can be used as lubricant in machine and in pencil lead. The use of the graphite is that it can be used as a lubricant in machine and in pencil lead because it is very soft. And why it is soft? Because the layers, these are held by the weak forces such that these layers can slide over one another. Here they have shown you layers of hexagon. These are the layers of the hexagon, and these layers of the hexagon are held together by weak forces, weak van der Waals forces. So also in graphite molecule, 1 valence electrons of each carbon atoms remain free, thus making graphite a good conductor of electricity. Now, why graphite is the good conductor of electricity? Graphite is a good conductor of electricity because it has one valence electron. Okay, it has one free electron, or it has one valence electron, because each in the structure of the graphite, each carbon atom is linked with other 3 atoms. Only one atom, there is one valence electron, there is one free valence electron, so which makes it a good conductor of electricity. Okay, so carbon-carbon binding forces are strong in hexagonal graphite crystals, so the melting and the boiling point are high. Now, why the melting and the boiling point of this graphite is high? Because the carbon-carbon binding forces, the carbon-carbon, 2 carbon atoms which are linked with each other, the binding forces are very strong in the hexagonal graphite crystals, so melting and boiling points are high. Okay, so what is the structure of the graphite? Hexagonal network of carbon atoms in graphite. Okay, hexagonal arrangement of atoms. This 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's why we are calling it as hexagonal arrangement. And one atom of carbon is linked with 3 other atoms. Each carbon atom is linked with 3 other atoms, and hence 1 electron remains free. So, which makes it as a good conductor. So, here are the properties of the graphite. That graphite, it's a grayish. All of you have seen the graphite also. This one is the graphite. This one is the graphite. It is used in the pencil lead because it marks the papers black. It marks the papers black. That's why you use it in the pencil lead. And this one is the graphite. It's a grayish black opaque substance with metallic lustre. And the density is 2.39 gram per centimeter cube. It is stable to heat and has a very high melting point. Its melting point is very high, 3700 degree centigrade, and it is soft and greasy to touch. If you will touch it, it is soft and it is greasy also, and it leaves the paper mark. It leaves a black mark on the paper. Now here they have shown you that graphite is a good conductor of electricity. This is the arrangement to show that graphite is a good conductor of electricity. This is graphite rod. This graphite rod is connected with the battery and with the help of the copper wire, and this copper wire is connected to the bulb, and here the other end of the graphite rod is connected to here with the bulb. So what happens when you switch on the current, the bulb will glow, showing that the current can pass through this. The current can pass through this rod and glow the bulb. So it means that it is allowing the current to pass through it, so it's a good conductor of electric current, and hence we can show that graphite is a good conductor of electricity. Now lead or pencil made up of graphite, and graphite crucible we can use. These are the crucibles of the graphite which we can use. We can melt the metals in it and keep molten metal, because its melting point of graphite is very high, 3700 degrees centigrade. That's why we used to make crucibles of the graphite, and these graphite crucibles, these are used to melt the metals.